Right, so now we're looking at differences of two squares. I'm going to show you differences of two squares, and then I'm going to talk only about using the box, because the method with the difference of two squares is only good in this one situation. The box is going to work for everything else we need. So we want to make sure that we understand how to do it for every problem, not just the special case. So in order for it to be a difference of two squares, there must be two things. The easy one, they have to be a difference. There has to be a subtraction, cannot be addition. And the other one is that you have two terms and they're both squares. So 16 is a square, that's 4 squared. Y squared is a square because it's y squared. And 4x squared is squared because it's the same thing as 2x squared. Back in chapter 5, if you were to multiply together a plus b times a minus b, and you put it in the box, you would end up as a final answer of a squared minus b squared. And some of you caught on to that, and that's good. Because now in this section, if you start with a squared minus b squared, you know you're going to get a plus b times a minus b. So this only works if you're looking at a difference of two squares. So it's one really quick method, but for a lot of people, if this doesn't stick in your head, don't worry about it. We'll show you the box, and the box works for everything. You don't have to worry about, is this a box? Is this a difference of two squares? This is just kind of a little piece of it that I wanted to share with you before we started into the box. So let's say we don't really remember much about chapter 5, and so we didn't see that whole a plus b times a minus b. Here's what we do. The first number goes in the first square. And the second number, and don't forget this minus is attached to the b, goes in the bottom squared. If you remember in chapter 5 when we were doing the boxes, we said, okay, what goes in this column, what goes in this column? The only way I can get b squared, and I can get negative b squared, is by saying negative b times b. The only way I can get a squared is a times a. Now I can complete the entire box from that information. Remember that these shared something in common, and I usually go right up this column. This one has a b, then that one had a b. Okay? If you're going across here, if this one has an a, then this one has an a. So it must have been a is an a. Looking at this bottom part here, just the bottom part, we're looking there and we said, okay, this is usually the one I do, negative b. So then in this column we have the a, okay? So this column gets the a. Now we have our factored example, and I'll show you a couple quick things here, but we have a minus b. And on the top we have a, and there's no sign. That means it's plus. You'll notice here is a times b, and here is negative a times b. And when you take these two parts and you add them together, you get 0. So you're left with a squared minus b squared, which is what we started with. So I know this is kind of complicated, but it becomes a step process. And if you can see the steps and take the steps and go with it, it really is very basic. So the first number goes in the first box. This one goes in this box. The second number, and remember if there's a minus, it goes with it. It goes in this box. And now we have to figure out what there is. So here's what we take back from 6.1 when we were looking at the factors of a monomial, something like 20x squared. We need to look at each box individually. This is negative 49. Negative 49 I could get by doing negative 49 times 1. I could do 7 times negative 7, or negative 7 times positive 7. But those are kind of my two possibilities to get negative 49. A lot of times you're going to notice that this one that has a 1 in it is not the correct one. It's a lot of times it's this one. Doesn't mean always, but very many times. So again, if we look at what we did, if we're rewinding what we did in chapter 5, we said, oh, what goes here, we just filled in straight down. So since I made this one -7, I'm going to back it up and say, well, then this one has to be -7, so that whole column has to have -7. To get 4y squared, there's lots of possibilities. Again, I'll show you the ones that are more typical, but for the 4, so this was for the -49, and for the 4y squared, it could be 2y times 2y. It could be 4 times y squared. It could be 4y times y. And what you'll see is rarely is this going to be the option. In order for it to work out, it's probably going to split the y's. Again, you might see this more than you see the one. So I'm going to start with 2y, 2y. It is important that you start doing your math in pencil if you've been using pen. And I know that you guys kind of go, okay, whatever. But we're going to do some problems where we're going to have to try it and erase it when it doesn't work. And that's the part I will not like, because with the pen is the only way I can do it where you can see it. So here we go. Let's keep going though. In this column, remember from chapter 5 that we said, okay, these two, whatever's here, we put here. So we know then this has to be 2y. If we come across this way, we know this one right here has to be the same in all boxes. So coming across this way, we have 2y and 2y. Here, we have to have something in common, and it's this one right here. 7 and 7 should be the same. So now what I should see as my factor to this is 2y positive 7, so plus 7 on the top, 2y minus 7. And we'll double check, we'll multiply these two boxes and see what happens. -7 times 2 is -14y. Positive 7 and 2 make 14y. These two would end up being added to a 0, so we'd get 4y squared minus 49. All right, so now let's talk about the steps to factoring. And again, I said if you kind of watch the steps, it's not so bad. The first step always is take out what they have in common. So when you first look at it, even though it pops in your head, oh, I got to do a box, you really need to see, is there something I can take out of both? So looking at this problem, can I divide 9 and 49 by the same number? No, not that I can think of. So look at the x's. One has 4 x's and one has 6 x's. I'm going to factor out 4 of those x's because they both share at least 4. So this one's x to the 4th times 49. So 49x to the 4th works out, minus x to the 4th. And what am I left with? Oh, I don't have the 9. I have 4 x's, but I need 6, so I need 2 more. I'm going to set this aside over here, and I'm left with 49 minus 9x squared. So now, is there anything else I can take out of those two parts? I don't see anything. So now I'm going to take it and put it into my box. I'm going to leave my x to the 4th power, and when I'm done, I should have something times something. So the first number goes in here. The last number goes over here. Now we go through our steps. We ask ourselves, say 49 could be 49 times 1 or 7 times 7. I'm going to go with 7 times 7 because most of the time the 1 isn't the right one. To get 9x to the 2nd, I know that I'm going to probably be looking at an x and an x of some sort. But how to get the 9 might be 3 times -3, 9 times -1, -9 times +1. I'm going to start with the 3's because a lot of times it ends up being that. And then if it doesn't work, we move on to the next one. So I'm going to say 3x and -3x create this. Backing it up, this column has all the same. If you noticed in chapter 3, I always took what was here and put it in these two spots to kind of keep it in a nice place. So we say, oh, this is the same as this, so it's the same as this. Then this column is -3x. If I go across here, we know that if you, like I said, if you watch what I did in chapter 5, I said, okay, whatever was here went here and here. Well, 7's here. Boom. Now I just got 2 more to fill out. Then again, looking in this column, when I did it in chapter 5, I said this one and this one, whatever was here. So if this one's 7, then this one's 7, and they're all 7. Going across, I said, okay, whatever was here went here and here. So we have 3x, 3x, 3x. So now I know what goes over here. I have 7 and a positive 3x, so that looks like this. And I have 7 and a minus 3x, and it's like this. This is the answer I think I'm going to have. I'm going to double check something. Negative 3 times positive 7 is negative 21x. 3 times positive 7 is 21x. These two will create that 0. So we end up with 49 minus x, 9x to the second, which is what we had here. So our final answer looks like that. We're going to do a couple more of these. Again, remember that the steps, the first step, what can I take out of both terms? So the first thing I'm looking at is the numbers, 18 and 50. They're both even, so I can divide both by 2. Is there anything larger I can divide the 2 by? Can I divide 18 and 50 by anything larger than 2? And I'm pretty positive I'm not going to find it. So I'm thinking, okay, it's going to be 2. Now this one has 2 A's and this one has 6 A's. So I could take out 2 A's and they would both have them in common. So here, to get this piece right here, I need 2 times 9 makes 18. I need 8 squared and I have A squared. I need B squared. Oh, I need B squared. Bring down the negative. This should be the same thing here. Okay. I need 50. 2 times 25 would give me 50. I need 6 A's and I have 2, so A to the 4th. Now I'm going to take that 2A squared out and set it aside. And I'm left with 9B squared minus 25A to the 4th. I look at it, I can't take anything else out of those two numbers. I know my final answer is going to have a 2A squared at the front and then something times something. The first part goes in this one and the last part comes to this one. Now it's where we start doing all the work. What's going to multiply together, and I'm going to start here because I think this one's going to end up being the easiest part. Again, it could be 9 times 1 or 3 times 3. So let's start with 3b times 3b. If it doesn't work, then we have to come back to this point and start all over again. But we think right now, looking at it, that's a good place to start. So remember, this column should all be the same. So if this one's 3b, this one should be 3b. So that means it's 3b. Going across, we're looking at 25a to the 4th. So now I'm looking at it going, okay, what could make 25a to the 4th? 5a squared times negative 5a squared. So that gives me the 25. It could be 25x to the 4th times 1. But in these problems, we're probably going to see that the equal splitting of the exponents. So let's try this one. 5a squared negative 5a squared. Again, these are all common, so boom, negative 5a to the 2nd power goes shum. If I go across here, this one and this one and this one all are common. So I'm just pulling it backwards from what I learned in chapter 5. And when I multiplied in chapter 5, whatever was here went here and here. So since this is 3b, this has to be 3b. So that column is 3b. I know this one is 3b and a positive 5a squared. 3b and a positive 5a squared. On this side, 3b minus 5a squared. Here I got negative 15a squared b, And here I get 15a squared b. Usually alphabetize them when you put them together. And they are opposites, so they are going to zero out. So taking that step again, what can I take out of both terms? And in the case of 64 and 25, are there any numbers I can divide both 64 and 25 by? Nothing that I see. But they both have x's and they both have y.